Test 1 2 1 2. Hello? Alright, perfect. We just had a little bit of technical issues, but now I'm back. Your favorite local procrastinator, Anon. And nothing can stop math right now because it's midnight and my brain is working at its peak capacity. But without further ado, let's skip the intro and... where is it? Yoink. There we go. Alright. For today, we got 8.3 applications to physics and engineering, and 9.1, which is modeling with differential equations. But he started as a header for 8.3. This one is... what is this about? Hydrostatic pressure and centroids. Okay, doesn't sound too bad. But first, the number one question we have is number 4, which is better expressed with a graph. If I can actually... oh, look! It's automatically turning into a line for me. Oh my god, look at this! Microsoft Whiteboard just turned my terrible hand-drawn line into an actual straight line. Okay, you know what? I kind of like this. But we have a triangle. How do I draw this triangle? Let's draw it this way. Line. Yes, line. Oh my god, this is so nice. But this is 5 feet. This is 10 feet. And the triangle is currently 2 feet below water. And we want to find the hydrostatic force. I assume we need to find the hydrostatic force on this little piece of... what even this is made of. Just our triangle here. And it's going to be on one side, right? Not both sides. I have no idea, but I'm going to do it anyways. Why is there a dot here? Excuse me? Please don't tell me I'm lagging already. I have barely started writing yet. No, I can't start lagging now. I haven't even started writing. But I'm gonna follow my... what do you call it? This formula up here. We want integral from 0 to 3, I assume. Hang on. Yeah, 0 to 3. Let's take the integral from 0 to... no, why did I say 3? This is my brain at its peak capacity. And then because this is in foot, or water density is going to be... it's 100 for meters. 62.5 if I remember right. Water density would be 62.5. Strip depths, that's how deep a single stripe is on the triangle. That's gonna be 5 minus y. And then the length of the strip. The length, this can be graphed as y equals 5 minus 1/2 x. So if we want everything in terms of y, that would be x is equal to 2y plus... wait a second. No. 10 minus 2y. Yeah. Am I doing this right? I sure hope I am. But yeah. Y is 5x 0. Good, good. So then we got 10 minus 2y dy. So we solve this, that is equal to 62.5 times, oh, there goes the bot again, from 0 to 5 of 50 minus, hang on, minus 10 minus 20y plus 2y squared dy, right? Double check. Yeah, I think that's right. So that's equal to 62.5 times 50y minus 10y squared plus 2 over 3 y to the power of 3 from 0 to 5. And that's equal to 62.5 times, plug in 0, we get 0 at least. So that's 250 minus 250 plus 250 over 3. So we get 62.5 times 250 over 3. Hang on, what are my units again? Pounds? Has to be pounds, right? Oh my god, I did not write out any units. I don't even remember the units. Haven't used units since chemistry. But I'm gonna guess this is gonna be in pounds. Let me double check. Oh right, this is an even number problem. Crap. Even number. But I can at least check my unit, right? It should be in pounds. Okay. Oh wait, is this not 62.5? Is this 64? Hang on. Water density. What is this water density we're supposed to use? In pounds per cubic foot. Well, no, it's 62.5. No, it's 62.4. Well, I'll just put 62.5. Looks a little cleaner. This is it. Do I have to calculate this? If so, then calculator. $62.5. Oops, 62.5 times 250 over 3 is this 0.3 pounds. That doesn't seem quite right. Maybe I did something wrong. I have no idea. Why do I have to start off with an even number question? But okay. In that case, just double checking with my notes. Yeah, this doesn't make quite that much sense. But have I done something wrong? Have I done anything wrong? Ten minus 2y. Five minus y is the depths. You know what? I think this is quite alright. Yeah, I think this is quite alright. If that's quite alright, then it's time to move on to number perfectly aligned. Number 7. Number 7 is a similar question. Oh yeah, watch these perfect Microsoft whiteboard lines. Number 7, we have an equilateral triangle. How am I going to draw an equilateral triangle? Oh, it doesn't have to be perfectly equilateral. Line? I didn't recognize that one as a line. This one's 100% a line. But why is it shaking like this? You know what? Go right there. So we've got 2 meter, yes, metric system. 2 meter every side. This is an equilateral triangle. And this is a water line, so it's perfectly right submerged underwater. And therefore, this has to be, oh god. Is it root 2 or root 3? This should be root 3, right? Wait, no. Oh yeah. I'm forgetting my triangles here. This is a 30, 60, 90 triangle, so that's 1, 2, root 3. Or is it? I'm doubting myself. Let me just write it out real quick. Yes, it is. Don't need to write it out. So we need to go from 0 to root 3. And because we have meters, we're going to use 1,000 kilograms per cubic meter. And that's going to multiply by 0 to root 3 of 2 minus y. Now here comes the interesting part. If we shift everything to one side, we get y equals x. Right? Y is equal to x. And then that's if we turn it into a triangle that looks like that. And oh god, what was I doing? Right, I was taking integrals. That is going to be equal to 1,000 times integral from 0 to root 3 of 2y minus y squared dy, which is going to be equal to 1,000 times the integral, no, not integral anymore, times y squared minus 1/3 y to the power of 3 multiplied, wait. My brain has ceased to function at its peak hour. But that's what I was going for. And then we simply plug things in. We get 1,000 times, plug in 0, get nothing. We get 3 minus root 3. Do I need to calculate that? Not gonna do that by hand. I don't like square roots. 3 minus root 3. This is 1,268 kilogram. That is going to be the force on our plate over here. And this is number 7. Does that... Wait, are my units wrong? Oh yeah, why did I write kilogram? This should be Newton, but even if it is in Newton, what is wrong here? The right answer is 9.8 times 10 to the power of 3. Wait, did I forget to put gravity in here? Wait a second. Do I need gravity? Huh? I'm gonna need to check my notes. This is how to do it. Oh yeah, gravity! Oh my god. But we add gravity would still not be the right answer. Let's see here. From 0 to root 3. Yeah, first off, if we use 9.8 as gravity, this should have been this. But that still doesn't fix this. Hello, Armin's husband. Wait. Hang on. I recognize that name. I heard the name Armin somewhere pretty recently before, I'm sure of it. Someone was mentioning it to me. It was like a character. Ah, my memory's terrible, especially at this hour of day. How's your night been going? I'm currently trying to figure out why I am dumb. 2 minus y is depths. Am I not allowed to do this? No. No way. Let's try that again. 3 minus square root of 3. This can't be. Drawing. Oh, that's cool. I cannot draw anything except for silly little graphs like this one. I'm just not made for it. But it's so cool when people can actually draw. I tried drawing before and gave up very quickly. You're amazing for persevering that far. I still need to know why I am not figuring this out. Am I on the right page? Yeah, this is 8.3. It's 8.3, but that's a weight density. Where are things going wrong? Practice certainly makes perfect, and I don't have enough practice right now. Can't really figure out what's wrong here. Could it be the textbook is wrong again? Because there's been quite a few times that the textbook was wrong already. How does this part turn to 1? if I do this a normal way, and I see this is the axis, then y equals 2x, x is equal to 1/2 y. But then we have two of them, so we multiply that by 2, we get y. Yeah, nothing's wrong here. What kind of sorcery is this? You know what? I'm gonna trust myself rather than the textbook this time. Because frankly, I don't know where this could have went wrong. Zero clue. But textbooks are wrong sometimes too, so let's move on. Number 9, let's see. I can't even draw a straight line. I have to let Microsoft Whiteboard draw the line for me. Like this. I hold it for a bit. Bam, a straight line. It looks so perfect. But this time we got a trapezoid. Okay, that looks okay. Trapezoid? Ah, the perfectionism is kicking in. No! Okay, trapezoid. I heard a follow sound. Thank you. Trapezoid. And what a not very good trapezoid, but the water line is gonna be about right here. This is gonna be in foot again. This is 1 foot. This is 2 foot. The top is 4 foot. The bottom is 8 foot. Okay, let's consolidate first. I don't know if that's actually what you call it. But if we simply put it this way. Line, please. Yeah, straight line. Beautiful. This is 4 foot. This is 8 foot. And our line's right here. This is 2 foot. This is 1 foot. So our equation for this line here would be y equals 8 minus x. That means we're gonna have the integral, or rather we have foot, so we can just use 62.5 times from 0 to 2. Our depth is 2 minus y, and or this should be x is equal to 8 minus y. Our length is going to be 8 minus y dy. Is that right? Plugging 2, we get 6. Sounds about right. Now, we can write that as 62.5 times integral from 0 to 2 of 16 minus 10y plus... Wait, did I miss a negative sign in the previous question? No, I didn't. That's another thing I usually do. When I think I might have made a mistake, I panic and check every single question I've answered so far. Plus y squared dy. That turns into 62.5 times... I hope we don't need to write the units out, because if we do, I'm getting a ton of points off here. 16y minus 5y squared plus 1 over 3 y cubed from 0 to 2. Which is equal to, if we plug in 0, we get 0. Therefore, this is 32 minus 20 plus 8 over 3. Why is my writing just slanting downwards? Which is equivalent to fractions. Time for a good old calculator. 62.5 times 32 minus 20 plus 8/3 is equivalent to 917 pounds. And pound is already before Zoedo. Ow. I don't even know what you call these units, but it's here. But also, why is my rectangles not perfect anymore? Last time, the rectangles were being turned into perfect rectangles as well, but now I just get straight lines. I guess straight lines is slightly better. But number 9. Hey, Arnabo, welcome back. Long time no see. I said I saw you not that long ago. Oh, that was like, yeah, that was weeks ago. It is mass again. Welcome back to Suffer. But apparently this answer is quite not on point as well, because the written answer is 889. That could be just because I used a different number for weight density. Yeah, you can just sit back and suffer through this with me. Find this entertaining. Well, torture can be quite entertaining if you have the right mindset for it. But am I doing something wrong? I could put the density weight into the graph and the function of differentials. It's function of the differentials. Yeah, I wasn't quite understanding what that meant. I don't know either. But we do have differential equations for the next section. I think this answer is close enough. I believe I used a different number for the density of water. I don't know what the textbook density of water is. I'm gonna leave it at that. But don't worry, because it's not over yet. We still have number 11, which is another similar problem. The density of water is the water's density. Man, if only my teachers could accept such a straightforward explanation. Now, we got conceptual questions. Oops. Ah, my line, my perfect line, my perfectly straight line. Perfectionism 100. But we got another upside down trapezoid this time. New Sonic game. Sonic has these weird geometries. Oh man, I can't draw this line. It keeps moving my line. There we go. Anyways, this is A, this is 2A, and this is H. Oh crap. Now, what do we use for the density of water here? I don't quite understand how they want me to do this. I guess I will just use a weird squiggly symbol. I remember someone told me what it's called. This is phi, right? Was it phi? I remember someone told me what it was called, but then I forgot. Anyways, if we consolidate this, oh yeah, the water line's right here. We get something looking like this. A to A. So X is equal to A plus Y, right? Hang on. No, right? No. I might be messing some stuff up. Yeah, no. This is... I'm really not doing very well right now. This is H. So let me graph this a different way. Y is equal to X minus A. Wait. My brain's not working because this is algebra. I need the slope here. That's gonna be rise over 1. H over A. Okay, so we have X equals 4 plus H over A Y. Seems about right. Therefore, we get water density times integral from 0 to H of H minus Y times 4 plus H over A Y dy. Am I understanding this right? We go from 0 to H and we're gonna have 4H minus 4Y plus H squared over A Y. Wait, yeah. And then plus H over A Y squared. No, that's a minus. That's a minus. Let me read the question again. Something doesn't feel right. Wait. Yeah. Where did I get 4 from? Where did I get 4 from? I don't know where I got 4 from. This is A. I think I was thinking of the previous question where we had a 4. And that just carried over. Minus 4Y. I got 4 from the depths of hell. But now what am I doing? Is anything else wrong? I think so. Because we're doing in terms of Y. This should be A over H, right? Yeah, probably. Where did I get the 4 from? Tell me. I would like to know. Even I didn't know what I was thinking. Oh no. Is the time up? No. I need to know. Where did the 4 come from? No. I need to know where 4 come from, and I also need to know what's Obama's last name. Wait, if it's A over H, then this is different. AY plus AY cancels out beautifully. Minus A over H Y squared dy. Damn. So Obama's last name has a 4 in it. Then we take that integral, we get AHY I minus A over 2H. No, A over 3H times y to the power 3 from 0 to h, which is equal to the thing times... No, please stop cutting off. I need to know. This is h squared minus a over 3 h squared. Plug in 0, get nothing. So this is equal to this thing. Times 2a over 4. Yeah. No, 2a over 3. A minus that times h squared. Is that right? This is number 11. Oh yeah, let's rewrite this. 2 over 3 phi, or as I should call it, density a h squared r squared, which is indeed the answer. Why is my perfect rectangle not coming back? Do I need to enable it somewhere? Oh yeah, enhanced ink shapes. Come here. I demand perfection. No. Please? Yes! My perfect rectangles are back. This is amazing. Anyways, now that we're done with 11, we got... Ooh. 15. Align perfectly. And 15, we have a cube. Imagine that's a cube with side lengths of 20 cm. Whereas I'm gonna write it 0.2 meters. It's sitting on the bottom of a 1 meter aquarium. So there's a 0.8 meter above the top of the rectangle, no, above the top of this cube. And there's two parts. A is find hydrostatic force on top of cube. And remember, right, hydrostatic pressure on top of cube is just the weight of the water above it. In which case that would be, or water density here, times 0.8 meters times 0.2 meters squared, which is equal to I have no idea if this is actually how it works, but it's worth a try. 313.6, and this is 15. I got that one right. I just missed the unit. I need to remember the units. I keep forgetting the units. And then B is the part we're actually interested in, which is one side of cube. So for one side of the cube, we need to take the integral first. Uh-oh, wrong color. Density times integral from 0 to 0.2 of 0.2, or rather, let's do it this way. 1 minus y times 0.2, which is a strip depth dy. So that's gonna be... I don't like decimals, not one bit. I should have written them in as fractions, and would have made it look a little cleaner. I am all fractions, gang. So this is 0.2. Let's write as fractions. 1/2. No. 1/5 y minus 1/10 y squared goes from 0 to 0.2. Plug in 0, you get nothing. Plug in 0.2, we get... Alright, equal signs. Calculator, do your thing. Calculator says the magic number is 352.8 newtons. Remember the units. Perfect rectangle, and that's right. Followed by 15, we have number 17, which also must be perfectly aligned. A swimming pool. Uh-oh, this is gonna be quite difficult to draw. Imagine a swimming pool. We've got a shallow end and a deep end. And there's a slope like that. So the deep end is 9 foot, shallow end is 3 foot. This is 40 foot long. But at the same time, it's 20 foot wide. So I don't even know what to call this shape. But oh my god, this question won a lot. There's 4 parts. A, hydrostatic force on shallow end. So I assume that's our square over there. And it's completely filled with water. We have foot, so we need 62.5. That is 62.5 times integral from 0 to 3 of 3 minus y times 20. Okay, this might not be so bad. Just rewrite it, expand it out. Keep rewriting. Now we take the integral. That's 60y minus 10y squared goes from 0 to 3, which if we multiply out, actually I'd rather, do I need a calculator for this? Yeah, there's decimals. I'd rather have a calculator do it for me. Times 60 times 3 minus 10 times 3 squared. We get 5,625 pounds because we got foot. And this 17, just double check real quick. Yeah, sounds about right. It's a little off because the decimal I used, but it's fine. Seems they rounded it. B wants to know the deep end. So basically same thing, except we now have from integral from 0 to 9. 9 minus y times 20 dy. And that's going to be equal to, let me move it down a little. 39, 180 minus 20y, which is equal to 62.5 times 180y. Wait, where's my 0? Good thing I realized in time. Somebody needs to scream at me when I make these kind of mistakes. And we go from 0 to 9. Wait, I just did it again. This is 10y squared. Let's have a calculator do that for us once again. It's gonna be 50,625 pounds. Wait, I wrote units for all my answers, right? Yeah, I did. Panic over nothing once again. Now, C wants to know one of the sides. So that's one of our trapezoids. Okay, but for the trapezoids, I need to know the equation. Strip depths. But if we turn it around, that's gonna look like this. 3, 9, 40. So y is equal to, what's the slope of this? 6 over 40 x. Okay. So x is equal to 40 over 6y. But that's only for the triangle part. We probably need 2 separate integrals for this. 62.5 times integral from 0 to 6 of 9 minus y times 40 over 6y. Is that right? Y is 6. Yeah. dy. And that's going to plus the rectangle portion, which is going to be from 6 to 9 of 9 minus y times 40 dy. I'm starting to not like this already, and we've just only begun. So 62.5 times integral of my algebra. 3 over 2. We got 40 over 6 is 20 over 3. So we got 60 y minus 40 over 6 y squared dy plus 62.5 or equal sign from 6 to 9 of 360 minus 40y dy, which is equal to, let's see, 62.5 times 30y squared minus, I think 20 over 3, 20 over 9 y cubed from 0 to 6 we should do it this way. This goes from 0 to 6 plus 360y minus 20y squared from 6 to 9. And now it is time for the calculator. Let me write this out first. 62.5 times 6 minus over 9 times 6 to the power 3. Ooh, precisely 600 plus 360 times 9 minus 20 times 9 squared. 1620 minus 1040. Which is equal to 48,750 pounds because we have foot. Is that right? About right. Now, where's the question? Here it is. Don't zoom in. I need my perfect 100% zoom. Now we got the final question D, which is bottom of the pool. $48,750 pounds of hydrostatic pressure. That's all I can tell you. It's how much force the water is putting on the side of the swimming pool. So next time you go to a swimming pool, just think about how tough the walls of the swimming pool has to be to withstand this amount of pressure. Well, it is diffused over a large surface area, but yeah. But now, we are gonna basically find out the mass of the water in the pool. Because of the trapezoid, I think we can even it out. So yeah. I don't know why would ever needs this kind of information, but we do have it. Math is all about getting the information you don't need. So we're gonna multiply by 6. That's 9 plus 3 over 2. I'm gonna actually write it as that. I wish I could multiply by 0 and call it an answer. Times 40 times 20. equal to. By the way, if I have to actually write down units for this, I am screwed. I have not been writing down any kind of units. That's gonna be equal to pounds of water. That's how much water is in a swimming pool. Is that right? No, seems like the textbook doesn't agree with me. Yeah, the textbook's not agreeing with me. Wait. How can this be? Quite frankly, I have no idea how to find the electrostatic or hydrostatic force on the bottom or top. The cube one worked out for some reason, but this one isn't. Oh, right. I think I understand why. Wait, but that doesn't make sense. Oh, I'm a complete idiot. I use Newton per meter cubed rather than what we're supposed to use. Times 9 plus 3 over 2 times 40 times 20. That's gonna be equal to how many zeros are 5 zeros? What a clean number. Let's check that again. 5 zeros, and that is correct. We just need pounds. Huzzah! Now that's 17 dealt with. Next up we have, hang on, where should I start writing? Align perfectly. That's a long line to go. Can I align this perfectly? Go straight down. Straight down. Down here. It's gonna be 23. 23 is about center of mass. Now let me just write down the question. So we have 3 points of mass. And we need to find the center of mass. Okay, this one shouldn't be too hard. So to find mx, we need to take all of the mass from y. I don't know how else I could say it. Plus, this is a top. Okay. 2 times 1. No, let's write 1 times 2. Plus 5 times 4, which is equal to 12, 28, 10. And y is equal to 2 times 4 plus or minus 3 times 2 plus 3 times 4. which is equal to 14. And m equals 3, so we have 10 over 3, 14 over 3. Is that right? This is number 23. Wait, no, something's wrong. Oh, find mx and y. So guess we need to write that down as well. Hang on a moment. Something's wrong here. Oh, right. My m was wrong. M goes to 4 plus 2 plus 4, which is equal to 10. Therefore, mx is equal to 10. My is equal to 14. The coordinates, center mass, that's called C. That's fine, right? Center mass is going to be the average of x, which is going to be my over m. So 14 over 10, 1.4. And then 10 over 10, 1. Please make it a good square. No, that's not good enough. No, not good enough. Can be better. What if I manually box it in? You cannot ruin my square like this, can you? Haha! Now then, we're done with 23, so let's move on to 28. 28 says that we want to find the centroid. Y is equal to sine of x, y equal to 0. X is between 0 and pi. Find centroid. So density is even all across the board. Now we need to first graph the function. So let's do just that. And this is a sine function from 0 to pi, so it looks like this, right? And we know there's a symmetry. Symmetry is that x is equal to pi over 2. So we already know 1/2 of the coordinates. The rest we would just need to find mx and m. So m is equal to integral from 0 to pi of sine x dx, which is equal to negative cosine x from 0 to pi, which is equal to 2. M equals 2. Now we also need mx, which is going to be 1/2 upper squared minus lower squared. So 1/2 sine squared x dx from 0 to pi, which is going to be 1/4 from 0 to pi of 1 minus cosine of 2x, which is equal to 1/4 times x minus 1/2 sine of x from 0 to pi. Plug in 0, we get 0. Plug in pi, we get pi. So this is pi over 4. Therefore, mx over m, which is our y coordinate, is equal to pi over 8. So our coordinate is going to be pi over 2, pi over 8. About right there. And even numbered question cannot check answer, but it makes sense. I mean, this answer is logical. It looks like it's right in the middle of where the entire thing is, so not gonna bother checking. But now we have ourselves question number 30. 30 says y equals 2 minus x squared, y equals x, find centroid. Normally we would have density in front of everything, but because there's density in front of both mx and m, they cancel out. So when we talk about centroid, where the density is the same all across the board, we don't need the phi. We don't need the density. And that makes things a lot easier. But actually, let's graph this equation first. Let's draw a little graph. Now, y equals 2 minus x squared. That's going to be a downward parabola. Downward parabola. Y equals x. That's going to cut through here. Cut through here. So that's 1, 1. That's -2. -4. Wait. No, -2, -2, right? Yeah, -2, -2. So it's easier to partition on the x-axis in this case. Which means, let's first find m. M is the integral from -2 to 1 of 2 minus x squared minus x dx, because our parabola is on top. So that's going to be equal to 2x minus 1/2 x squared minus 1/3 x cubed from -2 to 1, which is equal to 2 minus 1/2 minus 1/3 minus -4, wait, minus 2 plus 8/3. Which, calculator, please. My brain is not gonna work with algebra. And that's gonna be 9/2. 9/2. Now, let's find m, y, and mx. Mx is going to be, let's see, integral from -2 to 1 of 2 minus x squared minus x squared dx. Right. And that's gonna be equal to, can I just plug this into a calculator? -2 to 1 of 4 minus 4x squared plus x to the power 4 minus x squared dx. So that's gonna be 4x minus 5 over 3 x to the power 3 plus 1 over 5 x to the power 5 from -2 to 1 equals to 4 minus 4/3 plus 1/5 minus -8 plus 32/3 plus 32/5. Oh my god. Why? Why must you subject me to this pain? Calculator time. I'm not gonna solve all this by hand. Let's hope I don't type something wrong, because that would be a shame. You get a question wrong because you typed something wrong. That's gonna be -31/5 is what I'm getting at. My, on the other hand, should be a bit easier to solve because it's just -2, 1, and x times, you know, I think my brain stopped functioning. Hang on. Yeah, it is x times. X times 2 minus x squared times, no, minus x dx. You know what? Not really easier, but not like it matters. These are all pretty simple integrals. We get integral from -2 to 1 of 2x minus x squared minus x cubed dx. That's going to be equal to x squared minus 1/3 x to the power 3 minus 1/4 x to the power 4, all from -2 to 1. That's going to be 1 minus 1/3 minus 1/4 minus 4. Now I'm panicking about negative signs. Plus 8/3 minus 4. All right, so get 1 minus 1/3 minus 1/4. Something doesn't look right. Never mind. I think it's fine. And that is gonna be -9/4. Okay. Or y is gonna be mx/m, which is equal to I think it's 6.2 divided by 9 times 2. -1.38, about there. Well, x is gonna be my/m, which is gonna be... Wait. No. No. This can't be. Did I mess the order up? I messed something up, didn't I? Because y cannot be negative here. Can it? I don't think it can. Can it? Center of mass outside the shape itself? I mean, that's certainly a possibility, but I don't know if it is in this case. And this is an even numbered question. I'm gonna write as -0.5. And there's another bot. Wow, we can even buy viewers on Twitch. Incredible. 1.38. Anyways, we're not here for the nightmare. Be gone. We don't need you here. And I am internally conflicted. I'm very conflicted about my answer because this does not seem right at all. This is most definitely not right. Can be -1.38. Something's messed up here, like a negative sign. Something is not right here. Let me do my math again. Oh. Consolidate. This is a 5. I see it now. Wait, now what's this? Plug in -2. That would be even less right. Wait. I forgot my 1/2. Oh my god, I forgot my 1/2. It's always this kind of small problems. Minus, no. Plus 8 minus 40/3 plus 32, no, minus 2/5. -4.6. But that still wouldn't make sense. So -0.5 would make sense. But the other part doesn't. Probably does a y wrong. Double check. This just gets more and more confusing. I don't have an example in my notes. What if it's a problem with my integral? Let's check my integral. Integral is 2 minus x squared minus x squared -2 to 1. Yep, some part of my integral is wrong. That's right. That's right. Wait. Well, that's right. The integral is solved correctly. Then is a problem when I was plugging in numbers? Oh my god. What have I done? Something here is wrong. And to be safe, I'm gonna do that again. One half times course everything is wrong. This part has to be right. Minus -8 plus 40/3. Oh, minus odd power. That was a problem all along. A single negative sign. A single negative sign was the entire problem. So if we solve it correctly, we get 1.8. And then 0.4. That would make a lot more sense. This answer would make a lot more sense. Okay. Well, just in case, let me actually graph it out. And just test real quick. Looks about right. This answer makes a lot more sense. A single negative sign costs like 10 minutes of time. No, 20 minutes of time. Now then, onward to... Oh no. The whiteboard is starting to lag. We have too many drawings here. Onward to 33. The last question of this unit, actually. We got x plus y is equal to 2. And x is equal to y squared. I'm guessing we got to partition onto y this time. Graph it. Graph. X equals y squared, that's a horizontal parabola. X plus y equals 2, so... Wait. Isn't that just this? It's the exact same shape. It is the exact same shape. Okay. So that's gonna be, alright, x is gonna be 0.4 from this exact same shape as 30. Can't believe they give me a freebie like this. So x has gotta be 0.6 and y has gotta be... Wait, hang on, I confused myself a little. -0.5. -0.5. Right? This is the even number question. No, odd number question. Let's check. Hang on, no. Slight mistake. Oh, that's a 2. This is supposed to be 1.6, not 0.6. It's supposed to be 2 minus 0.4. Not... I mean, what? Not 1. That's what I was trying to say. So if we draw the previous shape, it looked like this. Or rather, upside down. It looked like this. And if it calls this the origin, we need to go up 0.4 and to the left 0.5. Hey, 3 point, I'll take it. Unless I get points off for this. But they literally gave me this question. There's no way I wouldn't be able to find this. It's the exact same shape, just in a different orientation. But that concludes Unit 8.3. And next up on the chopping block is 9.1. 9.1 is all about... What's 9.1 again? Oh. Modeling using differential equations. Okay, so what kind of questions are in 9.4? Number 2. Verify that y equals negative t. Let's zoom out a little. No. No, don't highlight. Number 2. Verify y equals negative t. Cosine t minus t is a solution of t times dy dt is equal to y plus t squared sine t. Y of pi is equal to 0. I don't like this already. Don't like this already. But first we must find y primed, or dy dt is equal to... Oh man. What was I doing? Oh yeah. Negative t. Or is it positive t sine t plus or minus cosine t minus 1. So t times t sine t minus cosine t minus 1 is equal to negative t cosine t minus t plus t squared sine t. And that is true. If we multiply it out, that turns into the exact same thing. My God, what am I supposed to do with this information? Y pi is equal to 0. Yeah, I can see that. I don't think I need to do anything with this information. But yeah, that's a solution. Okay, not terrible for first problem. Next up is number 3. Number 3 has 2 parts. For what values of r does the function e is equal to... Okay, let's write it this way. Y equals e to the power of rx is a solution to 2 times y double prime plus y prime minus y equals 0. Find r. Okay, I think I understand this one. Because y prime is going to be equal to re to the power of rx. Y double prime is going to be equal to r squared e to the power of rx. So 2r squared e to the power of rx plus re rx minus erx is equal to 0. So 2r squared plus r minus 1 equals 0. Because e to the power of something is never 0. So therefore, I'm supposed to solve this normally. How do I solve equation normally? 2r plus 1, r minus, wait, no. 2r minus 1, r plus 1 is equal to 0. R is equal to -1 and 1/2. Right. But that's just part A. There's also part B, which say if R1 and R2 are the values of R as they found in part A, show that every member of the family of functions every member of the function y equals, let me write the pretext first. R1 and R2 are values of R from A. Show that y equals A times e to the power of R1x plus b times e to the power of r2x is also solution. Okay, so or r1 r2 are -1 and 1/2 respectively, so y is equal to a times e to the power of -x plus b times e to the power of x over 2. That means y prime is going to be -a e to the power of -x plus b over 2 times e to the power of x over 2. And y double prime is going to be a times e to the power of -x plus b, am I doing this right? Plus b over 4 e to the power of x over 2. So if we plug that in, 2 times a e to the power of -x plus b over 4 e to the power of x over 2. What is it? Plus, or rather minus a. Actually, no. Plus for now. Plus -a times e to the power of -x plus b over 2 e to the power of x squared minus a times e to the power of -x plus b e to the power of x over 2. All right, we got 2a. We got let's write it out. I know this cancels out, but I'm gonna write it out anyways. 2 times a e negative x plus b over 2 e to the power of x over 2 minus a e negative x plus b over 2 e to the power of x over 2 minus a e to the power of negative x minus b e to the power of x over 2. So these cancel out and these cancel out, which means it's all equal to 0. And that's the solution. Now, number 7. Oh my god, we got more multi-part problems. A says y prime equals negative y squared. What can you say about one solution at a glance? Y equals 0. Simple as that. Y equals 0. If y is 0, then y prime is also 0. That's an obvious solution. Okay. Then B. Verify that, what is this? Y equals 1 over x plus c are solutions. Okay. Y prime is equal to natural log of x plus c. Wait, no. I just integrated. What am I doing? Okay. Quotient rule. So that's f prime g first, right? Wait. I don't remember the quotient rule. Is it top first or bottom first? But I can do this with product rule. Right? Or the chain rule. Negative x plus c. Chain rule is way easier. Power of negative 2. Which is basically 1 over, no, negative 1 over x plus c squared. Y, negative y squared is equal to negative 1 over x plus c squared, which is equal to negative 1 over x plus c squared. Y prime equals to negative y squared. Here we go. Part C. Find a solution not in the family from problem B. Okay. Y equals 0. Because y cannot equal 0 in this case. Another 3 point claimed. D. D says find solution. Y primed equals negative y squared. And y of 0 equals 0.5. In that case, then we can simply use a family from here, because 1 over x plus... No. Y equals 1 over x plus c, right? So y0 is equal to 1 over 0 plus c, which needs to equal 0.5. So c is equal to 2. Therefore, the solution is y is equal to 1 over x plus 2. Looked like a long question, but it was actually pretty easy. Now, number 9. Ooh. A population. Oh yeah, I'm totally in the mood now. I'm on a streak. Modeled by rate of change of the population over time is equal to 1.2 times population size times 1 minus p over 4,200. So 4,200 is like the holding capacity. Now this is also multi-part. A, what value of P is population increasing? So that means dp dt, the rate of change, is going to be greater than 0. Therefore, 1.2 p 1 minus p over 4020 is greater than 0. So p has to be less than 4,200. It also has to be greater than 0, but a population cannot be negative. Therefore, this is fine. Oh no, am I gonna run out of space? B. What's the value decreasing of P is population. Hello world! What's 2 O's and 2 L's? We are studying calculus. This is Calculus Early Transcendentals 2015 edition, or 8th edition. Chapter 9.1, Modeling with Differential Equations. A relatively easy chapter, if I have to say. So in this case, dp dt has to be less than 0, therefore 1.2 p 1 minus p over this thing has to be less than 0. Therefore, p has to be greater than 4,200. 4,200. P can also be negative, but population can actually be negative, so we disregard that. Now there's also part C. Part C says, what are the equilibrium solutions? Solutions. ODE, PDE? I'm not sure what that is. I'm not sure what those are. I haven't heard of ODE or PDE before. Is that like a chapter or a course? So equilibrium solution, this is equal to 0. Therefore, this thing, the model has to be equal to 0. P is equal to 0 or 4,200. Fantastic. Moving on to number 15. Oh, let me double check the answer. And yeah, of course, is the answer. I guess I should have put greater than 0. Ordinary differential equation, partial differential equations. I don't think we're there yet. We have done integrating partial fractions, but that's about it. We're not quite there yet, I don't think. Now, 15 is actually, last problem for the day. And we got an entire paragraph here. Psychologists interested in learning series study learning curves. A learning curve is a graph of a function PT, the performance of someone learning a skill as a function of the training time t. The derivative dp over dt represents the rate at which performance increases. Let's write down the important bits. Performance PT as function of time t. dp dt represents rate of improvement. Multi-part question once again. Part A. When do you think P increases more rapidly? What happens to... When do you think P increases most rapidly? What happens to dP over dt as T increases? What happens or what do you, I think this is an open-ended question, think P, or rather when do you think P increases most rapidly? Whiteboard's lagging out already, but we're almost done. Hold through this whiteboard. What happens to dP dt over time? If I were to talk about learning, I'd say performance would look something like this, where this is performance and this is time. As you get stuck at the front with a little learning curve, then suddenly you get good at it, and then you're just proficient at it. But how do I see that? I think I can give an easy answer, but I think he would increase most rapidly sometime after the start. Oops. I should put I think here, because there's no science behind this. This is just guesswork. Most rapidly short time after training starts. dp dt would decrease as time goes on. The rate of learning would probably start off very slow and then suddenly accelerate, and then just flattens out over time. But I think B is going to give us some actual science to this. If M is max level of performance, why does this differential equation make sense? K is a constant. It's really lagging now. I can't even draw keystrokes quickly. M is... Oh yeah, I already said M is max level. As P approaches M, dp dt approaches 0. That's why it makes sense. When you reach that max level proficiency, which you never will, well, as you get close to it, it goes way slower, and you'll never reach perfection. Just like real life. And let's just say a learning rate of 0 means no improvement. I guess that makes sense. That's the easiest way to have it make sense for me. C. positive. Case positive. C. Sketch. Possible solution to be easy enough. Just draw a graph. And this is our line M. This is our performance start. It will look like this. It starts ascending pretty quickly, but then it's slower and slower and never approaches M. That's basically how it looked like. Here is time. Up here is performance. And that will be it. Fantastic. 8.2 was done last week. Kind of went ahead because there was not enough things to do. And today we did 8.3 and 9.1. But now I'm curious. What's ordinary differential equation? Ordinary differential equations. And also, what's partial differential equations? Autonomous ODE, linear ODE, nonlinear ODE. It's equations that contains only one independent variable and one or more of its derivatives. Wait. Then this is exactly what this was. We got linear ODEs all over here. Linear ODEs all over the place. We got a nonlinear ODE. Wait, so this is what I've been doing. Never know what's called that. Now, a partial differential equation is commonly denoted as PDE. It's a differential equation containing partial derivatives of the dependent variable, one or more, with more than one independent variable. A PDE function, looks disgusting. But it's a differential equation with more than one variable. Does this count as PDE? No, I don't think so. No, this doesn't count. Have we had a PDE anywhere here? No. I don't think we have done a PDE, but we have certainly done ODEs. Well, there we go. That was all that needed to be done today. And hang on. How does this guy's name change in chat? Can the bot just keep changing their names? That's weird. I need to look into how bots work on Twitch. But anyways, your nightmare is over. You may have a blissful rest for the rest of the night. And I will see you next week. Goodbye, and have a good night's rest. Yoink.